Okay. So today we're going to be talking about recursion. And I know I've been saying like, oh, this is going to be a rough day. This is a rough topic to learn. It really isn't that bad. Okay? It's like the logic is all there. You just have to think about it in a weird way. It's kind of a weird thing that's going on with functions. So we're going to be talking about recursion, and then we're going to be talking about something that will help you understand it more. It's called the call stack, which is something that JavaScript creates for itself to understand which function to run at what time, at what point in time. So, what is recursion really? Recursion, let's say I have a function, and it says hi, again, right? I've been using this function like crazy. And all it does is console.log hi, right? So if I run says hi, you get hi in the console, correct? So the act of recursion is inside the function definition. You call it again. That is what recursion is, a function calling itself. So the function is you guys can, this is a good size, right? You guys can see this? Make it a little bigger? Better? I think that's better. So the function you're defining here says hi, right? And you can call this function itself. But what happens if you do this? Just like this? Oh, wait. Whoops. It goes on and on and on. Look how small oh wait, where is that error? Basically, you'll get an error, and it's going to say maximum call stack, whatever. It's just been called too many times, and it takes up so much memory, it maxes out the memory, and then the function breaks. If you guys have messed around with while loops, and you forget to like say while, if you say like while I is less than that, but you forget to increment I at the end of the loop, the same thing happens, an infinite loop, right? This is the same thing. This is what happens. So before you guys ask any questions, I'm gonna try and solve a problem recursively. I'm gonna show you how it's done, and then before you guys ask questions again, I'm gonna talk about what the call stack is. Then you guys can ask some questions, okay? So just bear with me for a second. What's up? Yeah. So forget this function. Let's say I have this array, right? Let's say I have an array called numbers, and I'm going to set it equal to 5, just an array of numbers, 5, 10, 20, 30. Okay? And let's say I want to write a function that adds up all of these things in the array. Right? This is not hard to do, right? So you would say function sum array will take an array, and basically what you would do normally, you would set let I, first you would say let total equals 0, and you say let I equals 0, I is less than array dot length, I plus plus. And then you would say total plus equals array at I. And then you would just return the total. So if we console.log sum array and then pass in numbers, we would get 65. Because 30 plus 20 is 50, plus 10 is 60, plus 5 is 65, right? This is a simple way to solve this problem. You don't have to do anything else. But the thing is, you can solve anything that you can solve with a loop, you can solve recursively as well. And I'll show you how to do that right now. So let's ignore all of this stuff. So the first part to tackling a recursion problem that you should be writing, this isn't like what's going on in the code, this is what you should be writing. So step 1 should be to define base case. What is a base case? A base case is basically a condition in the function that is saying, okay, run it again and again, but stop when this is hit. The base case is what tells your function to stop. So in this case, my base case will be if numbers, if array dot length is equal to 1, I'm going to return array at 0. I'll explain why I'm doing this in a second. So now that I have my base case, and I say numbers, then I'm going to say, after that, if this isn't true, so like let's say I'm passing in numbers in here, the length is 5, so what do I want to do after that? I want to say array at 0 plus equals array dot pop. This line in this code, line 17, is saying the array you're passing into here, array at 0, you're going to access the 0th index, 5, and you're going to add to it whatever is array.pop. And what is array.pop? It's 30, right? You all agree that if you did numbers.pop, it would be 30, right? But also, the length of this array is changing, right? Pop mutates the array, right? So then, after that's mutated, you say some array of array. Gosh. And you get the same thing. So this is how you solve that same problem recursively, okay? And all of you probably don't know what's going on. So before you guys ask any questions, I'm going to tell you about the call stack. So the call,
Excuse me?
yeah.
Can you just add console log, like what happens to the numbers? The array
So
gets mutated?
okay, so first I'll console.log array, right?
Okay.
The thing that's being put into here.
Okay. And outside, what happens like if you dot console log numbers?
Well, first
It
I
is
have to
still
run.
intact?
First I have to run array. No, no, the numbers is changed. Some array of numbers, right? And then I just console log numbers here. Numbers is now just 65.
Okay.
So that's, you are mutating in the array in this situation. But the point of this is that we're doing it by calling some array. Again, we're still getting the same answer. But we are mutating the array, but like whatever. So now I want to tell you guys about the call stack. Okay? Now, since JavaScript is a single-threaded language, that means JavaScript can run one function at a time. So the call stack JavaScript creates to use to see what function should be running at what point in time. So let's say we have, let me just get rid of this console log for a second and this. So let's say we have a function first. And first, just console.logs I am first. And then we have a function second that console.logs I am second. So first you invoke, and then second you invoke, right? So I am first runs, and then I am second runs. But what's going on behind the scenes is that if you have something that's called the call stack down here, first, the program is running through the code. It sees first is being invoked. So the function first is being put on the call stack, right? That function goes onto the call stack. Then it runs the function. Console logs I am first. It's done running. So then it's taken off the call stack. Then line 34, second runs. So second is put onto the call stack. And then second runs, console logs I am second. And then that is taken off the call stack. That's pretty simple to understand, right? The call stack, it's like a function's running, it goes onto the call stack. Once it's done running, it goes off the call stack. But what happens if inside first, I invoke second here and not here? What do you think would happen now? So let's run through it. It makes sense. So a function is only taken off the call stack when it's done running, right? So let's say these are function definitions, right? So JavaScript skips the code, and then it sees that first is being invoked. So first is automatically thrown onto the call stack, right? First is running. It will console log I am first, and I'll put this in here so you know that when first is done running. So first is invoked, first runs. It's thrown onto the call stack. So you go line by line. Let's see what's going on in first. We have a console log I am first. But then we have second being invoked. So now that second is invoked, second is thrown onto the call stack as well. But first is still on there because it's not done. But now JavaScript knows, okay, the running of first is paused. It's paused because now I have to run second. Because you're invoking it inside first. Then second runs, it console.logs I am second. It finishes running, so it's taken off the call stack. And then first continues, console.logs I am done. Well, done. And then first is taken off the call stack. Does everyone understand this concept of the call stack? Once a function is called, it is thrown onto the call stack. Once it's done running, it's taken off the call stack. If that function that goes onto the call stack, inside of it is calling a different function, the function it's calling goes on, but the bottom one is not taken off yet because it's not done running yet. Once this one's taken off and that's done running, then the first one can continue to run and then that's taken off. Okay?
Calling second inside the first function change the order that it was placed on the call stack at all?
What do you mean?
So in the first...
So if I called second here,
yeah,
and then I didn't call it here,
it
doesn't change the order, but first is thrown onto the call stack when it's running, right? Then first finishes running, so first is taken off. So now the call stack is empty, and then second runs, so then second's thrown on there. But if you call second in here, and you don't call it after you call first, then first is called, and it's not done yet because it has to call second. So then second is thrown on top of it. So first is not done, first is paused, it's not running anymore because second has to finish running before first can finish running. And that's the point of the call stack.
So they're not called simultaneously. It's not like first
No.
continues in the background while second.
No. That's the tricky part about JavaScript. JavaScript is single-threaded. It runs line by line. So that means it could run one function at a time.
Okay.
So the first function, when line 27 is hit, like you invoke it, so it's running this function. When this is hit, the first function pauses.
Okay.
Then the second function finishes running. This is done. It's off the call stack, and then you can finish first, and then that's off the call stack. That's the general concept of the call stack. So now that you have this knowledge of this, I'm going to show you what happens to the call stack when we call this function, okay? So let's say, let me just comment this out. Let me put this back in. Okay. So back to this recursive problem. Numbers is being thrown into some array, right? Here, right? So when you're invoking some array with numbers, the call stack is going to look like this. Some array, some array with this array. Correct? Right? When you call it, that's what's going to be on the call stack. Some array will be invoked with that array. So now let's walk through what is going to happen when that's passed into some array. This array goes through here. Here's this if statement, right? I can do this. Is this one line confusing anybody? Because I can make it into a block. Okay. So it says, if the array that's being passed into it, dot length is equal to 1, return array. So it's not, right? So we're going to skip this line and keep going. Now we're going to say array of 0, that array being inputted, so array of 0 is 5, is now going to plus equal array.pop. What is array.pop in this situation? It's 30, right? Everybody good on that? Array.pop is 30. But when you call array.pop, .pop is a method, right? So it's a function, and it's going to actually mutate this array. So now, array of 0, 5, should be 35. And then 30 should no longer exist. And then we are going to return a function invocation of some array again with that new array. So onto the call stack, some array the first time isn't done running yet. So now we're going to call it again with 35, 10, and 20, right? So now we're going to throw 35, 10, and 20 into the function again because you're calling it right here, the same function. What?
How did it became 25?
Because of this line, line 17. Array at 0 is the 5, right?
Okay.
You're plus equaling it to array.pop.
Okay, I couldn't see the plus.
Okay, so yeah, okay, right.
Yeah.
So now we're passing 35, 10, and 20 into this function. Is it equal to 0? Is it equal to 1, the length? No, it's 3, right? There's 3 things in it still. So you do the same thing. But now array at 0 is 35. You pop off 20, the array is altered, and you add it to 35. And then you return an invocation of that with the new array. So now on the call stack, you have some array of 55 and 10. Notice the call stack. The original function never finished running, correct? This function, the second time you called it, that's not done running either. Because now we're calling another function. So these two functions have to wait for this one to stop running. So now we pass through 55 and 10, an array with 55 and 10. Is the array length 1? No. So skip this return. Array at 0, 55, is now plus equal to array.pop. So 10 is taken out of the array, mutated, and then added to 55. And then we pass that, which is now just an array with one thing in it, 65. So now on the call stack, we have some array of 65. Okay? So, Now we're calling some array with just 65, an array with just 65. But wait a second, our base case, we are now telling this recursion to stop. It hits this base case, so it's never going to return some array again. Because if array.length is equal to 1, which it is, there's only a 65 in it, we are going to return array at 0. We're going to return the value at that position, which will be 65. So, since this is true now, this part of the function doesn't run again. So, this function stops running, and the result is 65. So now that this can be taken off the call stack, the return value of this is 65. So this is still 65, and then this is taken off the call stack because we're returning here. And then every time it just goes off, and then you come out with 65 as the return value.
What was the input? It was just a single array with multiple elements? Oh, okay. All right.
So because the final call, once we get the array length down, once we've added everything together and we have one thing in the array, this will return 65, right? Like, if we just passed in an array at 65, it will just return 65, right? Everyone agrees with that. So now, if you track backwards, before, the return value of some array of 55 and 10 is this, right? Some array of 55 and 10. But if we know, if we pass in, is the sum array of 55 and 10, the return value of this is now the return value of this. Because when you pass in 55 and 10, it's returning some array of 65. So that return value is now 65 as well. And then since that's the return value of this, the return value of this was this, but now this is 65. So then this is 65, the return value. And since the return value of this was this, but this is return now. This is 55. 65. So then this becomes 65 and it stops. If you don't put this base case in, maximum call stack size exceeded. It just keeps trying to pop something off an array that doesn't exist over and over and over again. So we need to tell it when to stop. Who's got questions? It's not a good sign. What's up?
Lines 26, 25, 24, you said those have the return value of 65 just because it's already gone through all those steps. And I'm wondering, are you telling me that it's 65 no matter what, or the potential of passing those different arrays are 65?
The potential?
The potential of going through the sum array being called sum array of that array, like 55 and 10.
No, if you pass these specific numbers in, the number will be 65,
Okay.
right? You add them together.
Yeah.
So basically, some array, once we have that number in an array still, right? So we're returning array of 0. So the return value of some array of this is 65, correct?
Yes.
But when this is called, this is returning this invocation. When you're calling this, it's going to return some array of 65.
Yes.
So the return value of some array of 65 is 65, right? We just decided that. So the return value of this is 65. And this is going to return the invocation of that, which we just concluded was 65. So this return value is 65. Same thing for this one. This returns the recursive thing of this. So this is now 65. You kind of, basically when you call a function over and over again recursively, when you call it again inside the function, you want to alter the thing you're passing in so that it eventually hits the base case. The base case, in this case, is that the array's length is 1. And every time we pass in some array, we pass in the array again. We are altering the array with pop. So the length, every time you call that array, is down by 1. And once you hit this, a return value is found, and the function is not called again. So then, it returns the value up until the original call. Two things that you need to remember when you're writing recursive solutions. Define your base case, and make sure you're altering the thing you're passing into that function. Okay? What other questions we got?
Can you repeat your last sentence?
The last sentence? What I just said? So two things. Define your base case. Know when the function should be stopping to run. Know when it should stop. And it should stop when the array length is 1. Because you don't want to do anything after that, right? Because when the array is 1, that value will have everything added into it.
That's my mistake.
And then make sure when you call the function inside of itself that you're not calling it with numbers. Like if you just say instead of pop, like if you don't mutate the array, right? And you just plus equals array at array.length minus 1. So array at array.length minus 1. Oh wait, this is wrong. Wait. So if you just add the first time down here, if you just add 5 with 30, because array at array.length minus 1 is always going to be the last element in the array, right? If you just do that and not alter the array, the call stack is exceeded again. Because instead of passing in 35, 10, and 20, you're passing in 35, 10, 20, and 30. And what it's going to happen is, since that array you're passing in is never getting shorter, this is never going to get hit. So what this function is now doing is adding 30 to 5 over and over again for infinity. And it'll never stop until the computer breaks. Does everyone understand that?
You always want to mutate whatever you're passing in.
Well, it depends. I mean, this specific question, since I'm doing this with an array, that would be, I mean, I don't have to mutate it, I guess. I can do it like this, and then return array dot slice of 0 to array at array dot length minus 1. Oh no? Return some array of array dot slice from 0. Oh no, that's the same thing. Minus 2. That's my bad. No? Why does this not work? Oh, because at the end it won't be like that. No, it should be fun though. Oh wait, that's what. So we're going to return this with array dot slice of 0 to array dot length minus 2. That's my bad. No? What is array dot length minus 2? Is there another console logs on it? Oh. Oh, minus 1. Oh, okay, cool. Confused myself for a second, sorry. So basically, you can not mute, and if you console log numbers at the end, it's still that, right? But if you console log this, if you console log the return value of this function, it's still 65. But you're not mutating the original array. The reason being is because, let me just delete this console log, that's my fault. The reason being, now, instead of array at 0 being added to array.pop, we're just adding it with the last thing in the array. But like I showed you before, then you can't pass in that array because you're not mutating it. So we make a copy with slice. Remember slice? You make a copy of it. And you slice off the last part. You just slice off that last element. And you always start at 0. So when you get down to here, 55 and 10, two things, runs through, adds 10 to 55 here, and then you slice off 0 to 1. Because the length is 2, subtract 1, 0 to 1, doesn't include the first index, so you only get the 0th index. Then this doesn't run again because what you're passing in is just 65. Okay? So now I'll go to the slides, and we're going to be talking about this with some simpler examples, and then talking about the call stack some more, okay? Stop me at any point during the slides, and I could code some stuff out for you guys. So in the overview of these slides, we'll be talking about the definition of recursion, what the call stack is. We'll go through a countdown example, a factorial example, recursion and arrays and strings, and tips for approaching recursion problems, okay? So the definition of recursion is recursion occurs when a function calls itself. Recursion is an alternative to iteration using a loop. So in the workshops, they're going to ask you to solve everything recursively. But in the real world, you don't have to solve anything recursively. You can solve it using loops. Anything you could solve with a loop, you can solve recursively. Anything you could solve recursively, you could solve with a loop. It's just another way of doing the problem.
But they said, like, isn't there certain times where you really can't solve it in the loop because you don't know what's inside of what you're passing in? Like, let's say that example that you gave, right, where you had a sum of all the array, right, and you had a single array. What if instead of a single array, you had all these embedded arrays and you were just to find out?
That we will go over in recursion 2
at
2 o'clock in array, like nested things.
Okay, yeah.
So Do you guys remember? I can't remember which workshop it was, but it was like a deeper copy. That was the problem. So we'll find out a way how to make not just one level deeper, but a multi-level deeper thing with recursion, which you can't do with a for loop. But like whatever. Basically, if you're like iterating through something, you could also do that recursively and vice versa. That's the basic logic there that I'm trying to get across. So in the real world, you may see recursion instead of iteration when a recursive solution is easier to reason about. So recursion helps break big problems into small chunks, which is true. You won't have to be writing like 30 for loops. You could just like recursively call, you know what I mean? It's easier to read than an iterative solution. Like again, there's a bunch of blocks of code you write with for loops. Recursion, you just call it. And it won't negatively affect performance too much. See, that's the thing about recursion. Sometimes it can be a memory hog. So machine learning, AI, and traversing data structures are just common examples of when recursion is used in the real world. Don't ask me when it's used for machine learning and AI because I've never worked with machine learning or AI. So I can't answer your questions.
Sorry, so recursion is more memory intensive than iteration?
Yeah.
Has to keep track of all the stats.
So before we talk about recursion, we have to talk about the call stack. Like I said before, JavaScript is single-threaded, so you can only run one function at one point in time. The call stack is the structure JavaScript uses to figure out which function it should be running at any point in time. Whenever we call a function, it's added to the top, and JS will execute whatever function is on the top of the stack. So this is the same thing that I showed you, right? The same thing. So you have the call stack over here, right? First is called. First it goes on the stack. Console logs I am first. First is taking off the stack. Second is put on the stack. Console logs I am second. Second is done running, so it's taken off the stack. Right? That's not hard to understand, right? So now we'll do an example, the countdown example. So write a function that counts down to 1. Easy, right? You just write a function, takes in a number. For let I is equal to that number, and you iterate through it and subtract I every time, and you just console log I. So 5, 4, 3, 2, 1 is what goes in the console. Right? This is okay. This is a simple function. It does a simple thing. So let's, is this the same thing? What the hell? Oh, this is that other thing the slides were out of order, sorry. So this is that other thing I was telling you about. First gets called, console logs I am first, but then second is put on the default call stack, and first is not taken off. We'll go back to the countdown thing in a second, but like you guys remember I talked about this too, right? First gets called, console logs I am first, inside first, second is being called, so second is going on the call stack, and first is not taken off the call stack because it is not done running. But now that second's on the call stack, JavaScript is like, all right, forget about first for a few seconds, let me call second. Second runs, you see in the console, I am second. Then, second is done running, so it's taken off the call stack. And this whole time, first was paused. So now that second's done running, and first is the highest thing on the call stack, it's the only thing on the call stack, so it's the highest, it finishes running. Okay? So let's refactor this countdown thing that I just showed you, writing a function that takes a number and logs it out. So countdown now, in this situation, just console logs a number. But if we wanted to do this and actually count down, we would have to call it every time with a different argument, manually. This is not programmatic. This is just like I'm calling this with a lower number every time. So you would get the same result. So we have to figure out a way to change the arguments, right? we have to figure out a way so that the arguments change themselves. So every time we called countdown, we subtracted 1 from the previous number. Instead of manually calling countdown over and over, why not have countdown call itself, subtracting 1 from each number, one from the number each time, right? So you say function countdown num, console.log num, countdown again, num minus 1. So what happens now? What's going to happen now?
Infinite.
Why?
Because it will keep doing minus 1, minus 2, minus 3.
You're never telling this function when to stop, right? So it's going to, you pass in 5, you're going to console log 5, then you're going to call countdown with 5 minus 1. So you're going to call countdown with 4. Then you're going to do it again, and again, and again, until you hit negative infinity. Okay? So countdown of 5 goes on, console logs 5. Countdown of 4 goes on, console logs 4. Countdown of 3 goes on, 2, 1, 0, negative 1. This is ridiculous. Negative 2. And so on. Until a range error comes out and the maximum call stack size is exceeded. It never stops. The memory of the call stack is just
How does it establish that maximum size before it gives you that error? Like what?
I think it hits the size in the actual place you're running it.
Okay.
So I don't know what the
Is
actual
it? Is it
size
based
is.
on the PC you're running it on, or something else?
Well, if you're running it in REPL, it's based on whatever REPL can
Oh,
handle.
okay. So whatever.
Yeah, so that because that's like an online thing, right?
Right.
But if you were like running functions in your own terminal, then it would be, I think, to your terminal,
Okay.
like to your computer's memory.
Right.
But like if it's gonna run fast, right? So if you just if it's infinite, it'll fill up like in no time.
Okay.
Yeah.
So the machine actually allocates it.
I think so. So everyone understands that this will run forever, right? You call this, it's just going to run forever. So that started off so promisingly, right? Because our function was instructed to call itself every time, the function ends up calling itself forever until our computer runs out of memory. So let's write in a stop condition so the function eventually stops calling itself. Here's our stop condition, commonly known as a base case. If number is less than 1, console log done. Here's our recursive case. Else, if it's not 1, and only if it's not 1, console log number, and then call countdown again with num minus 1. So now, countdown of 3 is being called, right? So that goes on the call stack. So what happens now? This is being called. 3 is the number. Is the number less than 1? No. So we hit this else condition. Console.log the number, and then you call countdown with 3 minus 1. You call countdown with 2. So you see, 3 is consoled, and then countdown of 2 is thrown onto the call stack. But countdown of 3 isn't done running yet because there was never any return value. Okay? So now that countdown of 2 is running, num is 2. Is num less than 1? No. So we go into here, console.log 2, and then you call countdown again. You invoke it with 2 minus 1. So countdown of 1 is then thrown onto the call stack. So what happens then? Is the number less than 1? 1 is 1. It's not less than 1. So no, that still isn't hit. So then you console.log 1, and then countdown of 0 is thrown onto the stack. So now, num is less than 1. Num is 0. So this else condition is not hit, and the console log's done. And what happens, this is not running anymore, right? So then that's done. So what happens when this function is done running. What does it implicitly return?
Undefined.
Undefined. So it is still getting a return value. So that means that countdown of 0, the return value is undefined. So all of these things can stop running because undefined is just passed back up. It's going to return undefined, but the point of this function is to just log things in the console, so that's fine. We don't care about that. Okay?
You're saying it's going to return undefined at 0 because the if statement doesn't like, specify to return anything, it just console logs done?
Yeah. So the function is a giant if-else, right? If the if statement is fulfilled, that thing runs, and then the else does not run, right? And if the if statement is not fulfilled for anything, the else will always run. So in the else is when we're actually calling the function again, it recurs. So if the if statement is hit, the else condition won't run, so then it stops calling itself. So then the returned value of this if statement, of the function then, when you're invoking it with 0, something is always returned when you're invoking the function. But if you don't tell it to return anything, it's just going to be undefined, right? Right? So then, this basically, if this is hit, forget about all this code. This is all that's left in the function. It's just console logging something. So then the return value is undefined. So the return value of countdown of 0 was undefined. So then the return value of countdown of 1 is countdown of 0. But countdown of 0 is undefined. So then countdown of 1 is undefined. And then the return value of countdown of 2 is countdown of 1. But countdown of 1, I just told you, was undefined. So then countdown of 2 is... You understand what I'm saying? But in this specific case, we don't care about what's being returned. We don't care about that. We're not setting the value of countdown of 3 to something. We just want to see it in the console. So that's why this is fine. This is just for console logging a countdown of the numbers and then done. Okay? So 2 takeaways from countdown. You need to define a base case. Your recursive case must change the input to the function so that you will eventually trigger the base case. These are the 2 main things when you're writing a recursive function, a recursive solution to something. Define your base case, and then when you call that function again, make sure the input will eventually hit that base case. Recursion becomes more complicated when the function must return a value, and it does. Good practice is to start by defining a base case. Base cases often occur when there is a simple input that expects a simple output. The sum of a single number is that number. Test that the base case works before working with the recursive case. That's another tip for solving recursive problems. You define your base case, and then you say, okay, I think I'm going to pass in this to when you call the function again. I think I'm going to want to pass in this. So test it. Call the function with the lowest number. Like in that problem before, try it with countdown of 1. To see what happens. If it, like try it with the smallest thing. Try it with like where you would think there would be 1 recursive call before you do anything. So let's go on to an example factorial. Factorial is just like a math thing. Like 2 factorial is 2 times 1. 3 factorial is 3 times 2 times 1. It's basically the number times everything before itself to 1. That's what a factorial is. And then factorial of 1 and 0 is 1. Okay? It's okay if you didn't know what this is. This is fine. Like, it doesn't matter. I'm just telling you right now, this is what a factorial is. This is the fact. So we're going to write a function. What look like simple inputs, outputs we can use to build a base case. Okay, so what do you think if we write a function that takes in a number and returns the factorial, right? And we're going to solve this recursively. What looks like a good base case?
0 and 1.
Yeah, why?
Because they have a definite value that you don't have to calculate
Exactly.
any further.
0 and 1 have definite values. The factorial of 0 and and 1 is 1. So we can say, let's just think, in our function, if we want to recursively call something, when the number that's being put into it is 0 or 1, the return value will always be 1. So that sounds like a pretty good base case, right? So function factorial number, base case num is 0 or 1. If num is equal to 0 or num is equal to 1, return 1. So if you do factorial of 0 and factorial of 1, you get 1 and you get 1, right? Cool. Okay, base case is set. Just need to remember that our recursive case has to bring our number closer and closer to 1 or 0. So we eventually hit our base case. Notice an interesting pattern. So, if we do let result is factorial of 2, and you console log result, you get undefined, right? Because we didn't put the recursive solution in there. So all that this is doing, we're setting result equal to the return value of factorial of 2. 2 gets passed in. Is it 0 or 1? No, so nothing is returned, so result is undefined. So let's put some logic in this function to make 2 also work for this. So the recursive case, we know that the num must get closer to 0 or 1, right? Right? So we know we have to call factorial again in the recursive case. If num is equal to 2, what do we get if we call factorial again with num minus 1? You get 1. So result is still undefined because we are not returning this. We are just console logging what would happen if you called factorial again with num minus 1. This is a little confusing. So you say result is equal to the return value of factorial of 2, right? Is that equal to 0 or 1? Is 2 equal to 0 or 1? No. Skips this, and then at the end, it console logs this, but like nothing's being returned. So this result is still undefined. But if you want to console log factorial of num minus 1, num minus 1 is 2 minus 1. 2 minus 1 is 1. So when you call factorial with 1, you do get a return value. So that's why you see the 1 up here. And that's why the 1 is before this console log. Because this function runs, it hits this, so then this function is called again. So then this is still on the call stack. But now another thing is on the call stack, factorial of 1. So then we hit this, return 1, so then that gets taken off the call stack, and then factorial 2 can finish running, and 1 is console log before this line is ever reached. Okay? So,
If that would be returned in the second situation,
if this was returned,
yeah,
if this was returned, then result would be 1.
that won't be any undefined.
No.
That's okay.
Because this function is not returning anything, unless it's 0 or 1, then factorial of 2 is undefined.
But I didn't understand. Like it hits to the console log first. Shouldn't
The console log
undefined
is the console log. What you're console logging is a function being invoked. So a function being invoked has a return value. It's either undefined or whatever the function is returning, right?
Okay.
So factorial of 2 is not done running yet because inside of it, we're calling factorial of num minus 1 inside the console log. Even though it's inside of a console log, the function is still being called because you're invoking it there. So factorial of num minus 1 is 1 because num was 2, right? So factorial of 1 does have a return value. It's 1. So then, once this returns, factorial of num minus 1 is now equal to the number 1. So then, this console logs 1. And then this is done running. So then we could go on to 3, which is still undefined.
Can you go back? Sorry. You said we can go on to 3 there, which is still undefined.
Then we could go on to 13, sorry. This is
Oh, line 13.
This is a 13.
Okay.
Because this is done.
Just console logging the result and there's nothing being returned, so that's just undefined.
Well, this, when you console log this does have a result. This does have a return value. It's 1.
Yeah.
So this console log is just console logging 1. It's not returning 1. If this was returned, like since this is 1, the result would be 1. But since we're just console logging it, nothing's being returned.
And that's where we get the undefined from?
Yeah, because if nothing's being returned in that function, undefined is implicitly returned. Undefined is automatically returned. Okay? So now we're still getting undefined here because we're still not returning anything. Don't worry about that. So now, let's say we pass into this solution. If num is equal to 0 or 1, it's not, skip it. So then we're hitting this console log. So num2 times factorial of num minus 1, right? So this returns something still, right? Factorial of 2 minus 1 is factorial of 1, so that's 1. So we're console logging that number times 1, which is actually how you get the factorial of 2. So now 2, this is correct if you pass in factorial 2. If we were to return this, then result would be 2. But this only works. No, I think this works for everything. No? So now, if you console log results, you do get 2. Because we're setting results inside of the function. So this is a different result than this one. We're setting results equal to num times factorial of num minus 1. So when you pass in 2, this if statement does not run. You guys are well aware of this by now. Then we're saying, hey, result, that will be equal to num 2 times factorial of 2 minus 1. 2 times factorial of 1. Factorial of 1 then runs. If num is equal to 0 or it's equal to 1, true, return 1. So this doesn't run anymore because we have this return right here. So then this is now 1. So now result is equal to 2 times 1. And then we return the result, which will be this. We console log that, and then we get 2. So now this seems like this will work if you pass in any number, right? So let's pass in 5, and let's see what's actually going on with the call stack. I think this will help you understand more what's going on, especially with return values. So you understand when we're setting this to a variable result, we say we define result as a variable, and we are assigning it factorial of 5. So results will be the return value of a factorial of 5. But to get that, we have to call factorial of 5. So we call factorial of 5. And the return value of factorial of 5 is 5 times factorial of 4. Who's confused by that? Okay. So you pass 5 in here. 5 is now num. Is num 0 or 1? No, it's 5. So this is not returned. But instead, we are saying let result is equal to num times factorial of 5 minus 1, factorial of 4. And then we were returning that result here. So the return value, once this is done running, will be the return value of this, 5 times factorial of 4. Right? So what is factorial of 4? That gets called because you're calling it here, so that goes onto the call stack, factorial of 4. Factorial of 5 is not done running, it's paused, because we have to find out what this is first. So 4 times factorial of 3 will be the return value of that, because it's not equal to 0 or 1. 4 is num, times factorial of 4 minus 1, 3. So now that we're calling factorial of 3, that gets thrown onto the call stack as well. Do you guys see a pattern? You guys understand, right? It's just going to keep on going and going until we hit factorial of 1. When factorial of 1 is passed in here, it returns 1. This isn't called anymore. This is not run. This line of code is done because we're returning the function here, 1. So the call stack of factorial of 1, the returned value is 1. So factorial of 1 is then taken off the call stack. But you see, this return value is 1, right? So factorial of 2, 2 times factorial of 1 will be 2 times 1, right? So then the return value of factorial of 2 is 2. So then, now that we know that what the return value of factorial of 2 is, factorial of 3, the return value, is 3 times whatever the return value was of factorial of 2, which is 3 times 2. So you get 6. And then factorial of 3 now returns 6, right? So then the return value of factorial of 4, that's the next thing on the call stack, since this is now about to be done running, we got 6 already. 4 times factorial of 3, factorial of 3 is 6. So you get 4 times 6, right? You get 24. Now, factorial of 4, the return value is 24. We've established that, right? So then 5 times the return value of factorial of 4, 5 times 24 is how you get the factorial of 5, 120. No matter how high of a number you put into this program, it will always subtract 1 and call itself every time, with 1 subtracted until we get to 1. Of course, it has to be a whole number in this case. So it was like 1.5 or 0.5. Either of those things are equal to 0. So, or like whatever. Does everyone what's up?
Can you explain what the purpose of the is?
Well, so apparently you can use recursion is super useful for like machine learning and AI stuff. It's useful if you don't really know what the function's input will be. So there are certain specifications, certain specific cases where recursion would be more useful, especially if you don't have to write a million loops. If you just call a function again, it's kind of cleaner to look at the code. But in most cases, in like 99% of cases, you don't have to use recursion, because if you can use recursion, you can use a loop. Like, at my job, never use recursion, because like I don't need to. This is just like, you don't
That
need
was
to.
going to be my next question.
Yeah, I never use recursion at my job because, you know, recursion isn't something that's like comes to people like that. So if you want to go back and look at a feature of your website that broke and you have to debug like a bunch of functions that you wrote to get data, having like a recursive thing is hard, because also console logging things gets a little weird with recursion, and you can kind of see already why, right? You don't really know at what point in time the console is being logged, which is why I'm going to tell you guys about the debugger thing in Chrome. So the Chrome DevTools has like a debugger feature. For some reason, when I was playing around with it at home last night, I couldn't get it to work when I was running code in REPL. But essentially, when you're running code, if you put in your function the word debugger, Chrome will stop everything, open up its DevTools. The DevTools have to be open, and then you'll see line by, it will take you through line by line of your function, and after it's done running that line, it will tell you what your variables are at that point in time. It's interesting. Look into it. Do your own research on that if you want to. So then you console log the results. It's 120. 3 takeaways from factorial. Write your base case first and test it using simple inputs or outputs. So we were testing that the base case worked with just inputting 2, right? Cool. Write your base case and test it using the simple possible input that results in 1 recursive call to the base case, which happened with 2. Test your function against more complex inputs will be the last part. You should try to use Chrome's debugger. It can help inspect recursive calls because console.log will not be as useful with recursion. You could still use console log. Don't think this is saying like, hey, never use console log with recursion. You could still do it. It just might get a little confusing. So the debugger tool helps. But like I said, I couldn't get it to work for some reason in my own code in REPL specifically. So maybe it'll work in a CodePen or whatever. So you can use recursion with any data type in JavaScript. If you're asked to recurse through arrays or strings, the base case often occurs when the iterable is empty or has a length of 1. You saw that in the problem I did before I started the presentation, right? So like when the input is going to be a number, the base case would be if we know like the factorial of 1 is 1, right? So we just subtract the number by 1 every time, and if the number is 1, return. If the input's a string or an array, we should stop it when there's only one thing left in the array, or if there's nothing left in the array. You go by the length of the string and the array. That's just common. I mean, maybe it's not for every single case, but that's just like a common thing to remember. So imagine finding the sum of numbers in an array. Sum array of 4. If array.length is equal to 1, the sum is easy to calculate, right? The sum of all the numbers in the array, there's one number, it's 4. That's it. So if the base case required the iterable to have a length of 1 or 0, it must mean that the recursive case has to reduce the length of the iterable with every recursive call. Makes sense. In our factorial problem, we subtracted the number by 1 each time. So this time, we will subtract from the length of the array by taking elements out of it. Nested arrays can be approached differently, and we'll talk about that in the next unit after this one. So cannot emphasize enough, start with the base case. Seriously, if you don't start with the base case, you will confuse yourselves very, very quickly. What's up?
I think like the hardest part for me is like when you have to initialize something that you're returning, right? Like you usually like let's say if it's a number that you're like take for example the sums, right?
Wait, the sums of the array
yeah,
or the factorial?
No,
Oh, okay.
yeah.
Yeah.
Whatever.
Yeah.
I usually say, you know, I define it by looking at it, and I would say, okay, this is what I'm going to return. I'm going to return the sum of all these values.
Yeah.
So I'm going to initially like sum equal to 0 because at first we don't have anything, right?
Yeah, but that would be only work for iterative solutions. So now that we're talking about recursion, we have to say, how can I call the function against itself and
Right.
still alter the thing that I'm passing
Right.
without setting another variable? Because when you call it again,
It's going to initialize to 0 again. With
again.
the way I have it.
so that's why I showed you in the example the pop.
Right.
The array is actually being mutated.
Okay. Yeah.
Or if you wanted to, like I did for an example that somebody said, you can pass in the same array with the first value
Right.
being updated and added to, but sliced off. So you don't actually mutate the array. So I think John has a good point. The hardest part, in my opinion, is to figure out what the base case is. Figure out what you should be returning. Figure out how the function should be calling itself and what should it actually be returning from the data you're passing into it. That's like the hardest part. But once you figure that out, once you know what your base case should be returning, then the rest should be a little more simple.
Because the iterative call is actually the easiest part to establish because it's
Yeah.
calling it itself. Like,
Exactly,
you're
yeah.
sure
But
you
like
need to-
usually, like if you're saying return a number, like the function, like the problem is like, hey, I want you to return this number. The base case should be returning a number. So now you have to figure out in the rest of your function how to make that possible, how to make the call again to get to that base case. So test your recursive case with the simplest possible input that will result in one recursive call to the base case. Ask yourself, what type of thing should my function return? Just said this 2 seconds ago. Base case and recursive case should return the same type of thing. Use console.logs or debugger to debug. And if you get stuck on a recursive problem, try writing it iteratively. You could do this if you wanted to. How you normally would at this point. Use a loop. It can reveal the inner workings of recursion to just see how you normally would do it if you wanted to do it this way. If you wanted to check it out, like maybe solve it with a loop first and then see, okay, how can I transform this into recursion? So we talked about recursion, the call stack. We did the countdown example where we're not returning anything. And then we did the factorial example where we are taking the return value and using it to call it again. And we talked about, I didn't show you, the slides didn't show you the example, but I showed you the example of how we could do it to sum an array. Get the sum of all the numbers in an array, right? Same thing would be for strings, except you're not summing anything in strings, but whatever. And then the tips. The tips are the most important part. Start by defining your base case. Figure out what that base case should be returning. Then call your recursive call with an input, a changed input, that will eventually hit the base case. Those are the two main things. And then like test it out and see how it's working with like the lowest possible recursive calls. What's up?
I have two kind of vocab questions. When we talk about iteration, we
We're
have
talking about loops.
yeah,
Well, iteration in itself is just like you have an array.
Yeah.
You have like a list of things, like going through each and every one.
Totally.
Is iterating.
I'm just wondering about verbs. Like for that, we can say like we iterate through something or
We
we loop
recurse
through
through it.
something. We recurse.
Yeah.
That's
I
is
think.
that how you're supposed to talk about it, or like
Yeah, you did like a recursive solution.
yeah? But is there a verb for it? Like we are recursing through.
I think that's what
That's
I
what it
don't
would
really
be. It sounds.
That's
kinda
what I
awkward.
say.
Okay,
That's
cool.
what I actually say, and I just never thought that I was right or not, but like, that's
Okay.
just what I said. Maybe a lot of people think I'm an idiot. I don't know. But yeah. Any other questions?
The other question is when we talk about iterables, the things that come to mind are like if you have an array, you can have multiple components, so you can iterate through like the array at
An
different
iterable,
elements.
I think, is an array
An array
and a string.
or a
Something
string
you
if it's
can
like an
iterate through.
index. Yeah.
No, an iterable, I think, is just something that you can iterate through.
Uh-huh.
So like things with indexes, like arrays, even objects, because you
Objects.
could do a foreign loop. You could loop through all the keys.
Yeah.
It's just not ordered.
So it's basically like arrays, objects, and strings because each component, each letter in the string. would
Yeah,
have an
those are
index,
all
so
iteratables.
That's all it would be.
Any other questions before you guys take a break and start this workshop? See, recursion isn't really that bad, right?
Just that base case.
It's just like you call the function again and something happens.
I think the factorial example is just confusing if you haven't internalized what a factorial is.
Factorial is just
I
like,
get,
yeah.
Yeah, I was more
in
confused about
theory, I get
factorial.
it.
No, for sure, yeah.
Yeah.
Like, that's why I-
You know, it's like it almost like stops you before you can start because you're like, crap, now I have to
Do you still not know what a factorial is?
I get it now.
What is it? Tell me.
It's like if factorial of 5 is 5 times 4 times 3 times 2 times
Exactly.
1, and so on. Yeah. But then it's like if that's a factorial of 5, it doesn't recognize factorial then, right? As like an idea. Like that's why we had to create that. We were creating a factorial.
Oh, like yeah, there's no like plus times this. That would be like, oh, this is the factorial.
Right.
Yeah, you have to make a function that gives you that. All right, take 5. We'll start the workshop. And I will help you guys with every help.